Weak references. lib/weakref.py. The weak reference module allows the Python programmers to create weak references to object. In the following, the term referent means the object which is referred to by a weak referent. A weak reference to an object is not enough to keep the object alive. When the only remaining references to a referent are weak references, garbage collection is free to destroy the referent and reuse its memory for something else. However, until the object is actually destroyed, the weak reference may return the object even if there are no strong references to it. A primary use for weak references is to implement caches or mappings holding large objects when it's desired that a large object not be kept alive solely because it appears in a cache or mapping. For example, if you have a number of large binary image objects, you may wish to associate a name with each. If you used a Python dictionary to map names to images or images to names, the image objects would remain alive just because they appeared as values or keys in the dictionaries. The weak key dictionary and weak value dictionary classes supplied by the weakref module are an alternative, using weak references to construct mappings that don't keep objects alive solely because they appear in the mapping objects. If, for example, an image object is a value in a weak value dictionary, then when the last remaining references to that image object are the weak references held by weak mappings, garbage collection can reclaim the object and its corresponding entries in weak mappings are simply deleted. Weak key dictionary and weak value dictionary use weak references in their implementation, setting up callback functions on the weak references that notify the weak dictionaries when a key or value has been reclaimed by the garbage collection. Weak set implements the set interface but keeps weak references to its elements, just like a weak key dictionary does. Finalize provides a straightforward way to register a cleanup function to be called when an object is garbage collected. This is simpler to use than setting up a callback function on a row weak reference, since the module automatically ensures that the finalizer remains alive until the object is collected. Most programs should find that using one of these weak container types or finalize is all they need. It's not usually necessary to create your own weak references directly. The low level machinery is exposed by the weak reference module for the benefit of advanced uses. Not all objects can be weakly referenced. Objects which support weak references include class instances, functions written in Python but not in C, instance methods, sets, frozen sets, some file objects, generators, type objects, sockets, arrays, dequeues, regular expression pattern objects, and code objects. Several built-in types such as list and dict do not directly support weak references but can aid support through subclassing. Class dict pass object is equal to dict red is equal to 1, green is equal to 2, blue is equal to 3. See Python implementation detail. Other built-in types such as tuple and integer do not support weak references even when subclassed. Extension types can easily be made to support weak references. See weak reference support. When underscore underscore floats underscore underscore are defined for a given type, weak reference support is disabled unless a weak reference string is also present in the sequence of strings in the slots declaration. See slots documentation for detail. Class weak reference dot ref object callback. Return a weak reference to object. The original object can be retrieved by calling the reference object if the referent is still alive. If the referent is no longer alive, calling the reference object will cause none to be returned. If callback is provided and not none, the returned weakref object is still alive. The callback will be called when the object is about to be finalized. The weak reference object will be passed as the only parameter to the callback. the referent will no longer be available. It is allowable for many weak references to be constructed for the same object. Callbacks registered for each weak reference will be called from the most recently registered callback to the oldest registered callback. Exceptions raised by the callback will be noted on the standard error output but cannot be propagated. They are handled in exactly the same way as exceptions raised from an object's DEL method. Weak references are hashable if the object is hashable. They will maintain their hash value even after the object was deleted. If hash is called the first time only after the object was deleted, the call will raise type error. Weak references support tests for equality but not ordering. If the referents are still alive, two references have the same equality relationship as their referents regardless of the callback. If either referent has been deleted, the references are equal only if the reference objects are same object. This is a subclassable type rather than a factory function. Underscore underscore callback underscore underscore. This read-only attribute returns the callback currently associated to the weakref. If there is no callback or if the referent of the weakref is no longer alive, then this attribute will have this value. weakref.proxy object comma optional callback. Return a proxy to object which uses the weak reference. This supports use of proxy in most contexts instead of requiring the explicit dereferencing used with weak reference objects. The returned object will have a type of either proxy type or callable proxy type, depending on whether object is callable. Proxy objects are not hashable regardless of the referent. This avoids number of problems related to their fundamentally mutable nature and prevents their use as dictionary keys. Callback is the same as the parameter of the same name to the ref function. Accessing an attribute of the proxy object after the referent is garbage collected raises reference error. weakref.getWeakrefCount object. Return the number of weak references and proxies which refer to object. weakref.getWeakrefs object. Return a list of all weak references and proxy objects which refer to the object. Class weakref.weakKeyDictionary dict. Mapping class that references keys weakly. Entries in the dictionary will be discarded when there is no longer a strong reference to the key. This can be used to associate additional data with an object owned by other parts of the application without adding attributes to those objects. This be especially useful with objects that override attribute accesses. Note that when a key with equal value to an existing key but not equal identity is inserted into the dictionary, it replaces the value but does not replace the existing key. Due to this, when the reference to the original key is deleted, it also deletes the entry in the dictionary. Class tstrPass k1 k2 is equal to tt instances of t. D is equal to weakref.weakKeyDictionary. D of k1 is equal to 1. D of k2 is equal to 2. Delete key D. Weak references. Data types. Perfect. Let me move this to this. example. That example. Weakref, import weakref. Print d print d and then print d after deletion of k1. Run weak reference object and display dict. Weak key dictionary. Dot values. Dot values. Both are same. D dot keys. Div display dict. Dict for v in for k in dict dot okay dict dot keys print key print dict dot key display dict d display dict d run 2. हेलो 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 क्या 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 हाँ लेते आओ okay display dict y2 only y2 okay print equal and is equal to this okay 2 and then nothing so keys okay if I say k3 and then here t instance and put d of k2 equal to 4, that 4, because all the references are same, that's why. Okay. A workaround would be remove the key prior to the reassignment. Class T str pass k1 k2 this, d is equal to weakref dot this, k1 is equal to this, delete k1, delete. Okay. Okay. Weak key dictionary objects have an additional method that exposes the internal references directly. The references are not guaranteed to be live at the time they are used, so the result of calling the references needs to be checked before being used. This can be used to avoid creating references that will cause the garbage collector to keep the keys around longer than needed. Weak key dictionary.keyrefs. Return an iterable of the weak references to the keys. Class weak reference dot weak value dictionary dict. Mapping class that references values weakly. Entries in the dictionary will be discarded when no strong reference to the value exists anymore. Weak value dictionary objects have an additional method that has the same issues as the key dictionary dot keyrefs method. Weak value dictionary dot value refs. Return an iterable of the weak references to the values. Value refs. For I refs in d dot value refs print d dot value refs. Okay, this is class weakref dot weak set elements sets class that keeps weak references to its elements. An element will be discarded when no strong references to it exist anymore. Class weakref.weak method callback, a custom ref subclass which simulates a weak references to a bound method defined on a class and looked up on an instance. Since a bound method is ephemeral, a standard weak reference cannot keep hold of it. Weak method has special code to recreate the bound method until either the object or the original function dies. Example 2. Import weakref. Import weakref. Garbage collector. Import gc. Import gc. Print 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 r gc dot print gc.collect. बोल print r method called weak reference dot weak method. Callback is the same as the parameter of the same name to the ref function. Class weakref.finalize object function slash pointer args pointer keyword args return a callable finalizer object which will be called when object is garbage collected. Unlike an ordinary weak reference, a finalizer will always survive until the reference object is collected, greatly simplifying lifecycle management. A finalizer is considered alive until it is called, either explicitly or at garbage collection, and after that it is dead. Calling a live finalizer returns the result of evaluating func pointer arg pointer keyword args, whereas calling a dead finalizer returns none. Exceptions raised by finalizer callbacks during garbage collection will be shown on the standard error output but cannot be propagated. They are handled in the same way as exceptions raised from an object delete method or a weak reference callback. When the program exits, each remaining live finalizer is called unless its at exit attribute has been set to false. They are called in reverse order of creation. A finalizer will never invoke its callback during the later part of the interpreter shutdown, when module globals are liable to have been replaced by none. Underscore call. If self is alive, then mark it as dead and return the value result of calling function point star args star keyword args. If self is dead, then return none. Detach. If self is alive, then mark it as dead and return the tuple object function args kw args. If self is dead, then return none. Peek. If self is alive, then return the tuple object function args kw args. If self is dead, then return none. Alive property which is true if the finalizer is alive, false otherwise. At exit, a writable boolean property which by default is true when the program exits. It calls all remaining live finalizers for which at exit is true. They are called in reverse order of creation. It is important to ensure that func args and kwrs do not own any references to object, either directly or indirectly, since otherwise object will never be garbage collected. In particular, func should not be a bound method of object. Weakref.reference type. The type object for weak reference is object. Weakreference.proxy type. The type object for proxies of objects which are not callable. Weakref.callable proxy type. The type object for proxies of callable objects. Weakref.proxy type. Sequence containing all the type objects for proxies. This can make it simpler to test if an object is a proxy without being dependent on naming both proxy types. Weak reference objects. Weak reference objects have no methods and no attributes besides ref dot underscore callback underscore. A weak reference object allows the referent to be obtained if it still exists by calling it import weak reference class object pass object r weak r weak reference dot ref object o2 is equal to r o is o2. Example 3. So o is o2. Print o is o2. So both should be true. If the referent is no longer exists, calling the reference object returns none. Calling the reference object returns none. Deleted o and o2 and now calling the referent. It should print none. Testing that a weak reference object is still live should be done using the expression ref is not none. Normally, application code that needs to use a reference object should follow this pattern. R is a weak reference object. OR. If O is none, referent has been garbage collected. And let's see, object is still alive. O dot do something. Print. Do something with object. Run. If I remove this object, do something with object. For example, here we have method diff diff print. Diff display, and wherein we print just I am still alive. So we can do O dot display, right? I am still alive, and if we delete it, then object has been deallocated, can't provisionate. Using a separate test for liveness creates race conditions in threaded applications. Another thread can cause a weak reference to become invalidated before the weak reference is called. The idiom shown above is safe in threaded applications as well as single threaded applications. Specialized versions of ref objects can be created through subclassing. This is used in the implementation of weak value dictionary to reduce the memory overhead for each entry in the mapping. This may be most useful to associate additional information with a reference, but could also be used to insert additional processing on calls to retrieve the reference. This example shows how a subclass of ref can be used to store additional information about an object and affect the value that is returned when the referent is accessed. Import weak reference. Class extend reference weak reference dot ref diff init self ob callback is equal to none slash pointer annotations super dot init ob callback self dot counter is equal to 0 for kv in annotations dot items set attribute self kv diff call return a pair containing the referent and the number of times the reference has been called. Ob is equal to super dot call. If ob is not none, self dot counter plus is equal to 1. Ob is equal to ob self dot counter return ob. Example. This example shows how an application can use object IDs to retrieve objects that it has seen before. The IDs of objects can then be used in other data structures without forcing the objects to remain alive, but the objects can still be retrieved by ID if they do so. Import weakref ID to object dictionary weak reference weak value dictionary diff remember object oid is equal to id object dictionary dot oid is equal to obj return oid diff id to object oid return oid. Finalizer objects. The main benefit of using finalize is that it makes it simpler to register a callback without needing to preserve the returned finalizer object. For instance, import weakref class object pass canny is equal to object weakref.finalize canny print you killed canny finalize object add for an object delete canny you killed canny. The finalizer can be directly and can call be called directly as well. However, the finalizer will invoke the callback at most once. Div callback xyz, print callback, return xyz, object is equal to object, f is equal to weakref dot finalize, object callback 1 2 3, 1 2 z is equal to 3, assert f dot align, assert f is equal to 6, callback f is equal to 6, callback assert not f dot alive, true, f delete object. Example 4. Callback run. None. Print I, print y, print gg, print run, true, none, object has been deallocated. Before, callback hi, true, y, gg. Okay. You can unregister a finalizer using its detach method. This kills the finalizer and returns the argument passed to the constructor when it was created. Object obj f weak reference finalize detach deregister finalize new object funcs args assert not alive assert new object is object assert func argument is equal to 6 callback Unless you set the at exit attribute to false, a finalizer will be called when the program exits if it is still alive. For instance, object obj weak reference print obj dead or exit call at exit exit. Comparing finalizers with underscore underscore deal underscore underscore methods. Suppose we want to create a class whose instances represent temporary directories. The directories should be deleted with their contents when the first of the following event occurs. The object is garbage collected, the object remove method is called, or the program exits. We might try to implement the class using a underscore underscore delete underscore underscore method as follows. Class temp directory init self.name is equal to temp file.mkd make directory temp diff remove self if self.name is not none shutil.rm tree self.name is equal to none property diff remove self return self.name is none diff delete remove self. Starting with Python 3.4, deal methods no longer prevent reference cycles from being garbage collected, and module globals are no longer forced to none during interpreter shutdown. So this code should work without any issues on C Python. However, handling of deal methods is notorious implementation specific since it depends on the internal details of the interpreter's garbage collector implementation. A more robust alternative can be to define a finalizer which only references the specific function and objects that it needs rather than having access to the full state of the object. Class temp directory diff init self.name is equal to temp.mk make directory temp self.finalizer is equal to weakref.finalize self shutil.rm tree self.name remove self.finalizer property removed return not self.finalizer after life. Defined like this, our finalizer only receives a reference to the details it needs to clean up the directory appropriately. If the object never gets garbage collected, the finalizer will still be called at exit. The other advantage of weak ref based finalizers is that they can be used to register finalizers for classes when the definition is controlled by a third party, such as running code when a module is unloaded. Import weakref, sys diff unloading underscore module implicit reference to the module globals from the function body weakref.finalize sys.modules underscore underscore name underscore underscore unloading volume. If you create a finalizer object in a dynamic mode just as the program exits, then there is the possibility that the finalizer does not get called at exit. However, in a daemonic thread at exit.register try finally and with do not guarantee that cleanup occurs.